these notes are what you need to have. Okay, so if you don't have these, there's a link in Canvas. Make sure you read all the instructions, and we're going to practice proofs. Okay, so first we need to label, okay? So label the diagram first. That's what you always need to do with proofs, okay? So this top part of the notes, okay, kind of this top section kind of shows what you should be thinking about when you do your proof, okay? So these two parts will be the same thing, but this is kind of like your thought process. And then the bottom part is what you're going to take your thoughts and put it in here and make it a nice, concise proof, okay? So label the diagram with the following information. So BD, that means perpendicular, right? So I'm going to say BD, so here's BD, is perpendicular to AC. So this is when it's helpful to have different colors. So perpendicular means 90 degrees. Okay, so did that one. All right, D bisects AC. So remember, AC is what's being cut in half. When you cut something in half, you get two congruent parts. Okay, and if it's a segment, those two parts are segments. When you're cutting an angle in half, those two parts would be angles, but we're cutting a segment in half, so we get two congruent segments. Okay, so then make sure you mark that. So AD is congruent to DC. So from this information, I get AD is congruent to DC. Okay, list the postulates that you can use right now to prove that you're congruent. So far we've got a side and an angle. So, well, list all of them. So we'll just list all of them that are available. So we have side, 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 angle, side, angle, angle, side, angle, side, angle, and hypotenuse leg. Okay, so we have all those options right now. Okay. So then, all of these have three parts to prove that two triangles are congruent. Hypotenuse leg is a different one. You only need two parts, but that's because it forces, if you have a congruent hypotenuse and a leg, it forces that other leg to be, the other pair of legs to be congruent to themselves because of a squared plus b squared equals c squared. Okay, all right. So what type of angles are formed when two perpendicular lines intersect? So right angles. Okay, so this one is needed to go through your head while you're doing proofs like this. Okay, let's see, what does angle ADB and what does that tell us about those two angles? ADB, so ADB and CDB. Okay, that means they're congruent. Okay, because all right angles are congruent because they're all 90 degrees, right? What happens when a point bisects a line segment? Cuts the line segment in half. Okay, so yielding two congruent segments. So what does that tell us about the relationship between the point D and A and line segment AC? That D is the midpoint, and then AD is congruent to DC. Okay. So, which postulate can you use to prove that these two triangles are congruent? So remember, you need 3 parts, 3 congruent parts to prove 2 triangles are congruent. Okay? So right now we only have 1, because those angles, and 2. I need something else. Okay? So right now we have that angle ADB is congruent to angle CDB. Why do we know that? Because they're both 90-degree angles. Okay? We know that AD is congruent to DC. Why do we know that? Because we found out that D is the midpoint. Okay? So we've got 1, 2, and we need a third one. All right, we don't know anything about any of the angles except for the 90 degrees, but we do know that these 2 triangles share this side BD. So it's congruent to itself. So I know that BD is congruent to BD. So that's called the reflexive property. Okay, so now I have 3 parts. So now if I look, this makes it side, angle, side. So triangle ADB is congruent to triangle CDB by SAS, my favorite. Okay, so you're going to take that information and we're going to kind of break it apart and put it in a nice proof. Okay? Okay. So so you're given here. Okay? So let's mark it. So BD is perpendicular. It's the same as up here, is what we're given up here. So I'm just going to put it down here, what we already know. Okay? And then we knew that AD and DC were congruent to each other, and then we knew that BD is congruent to itself. Okay, so that's what we gathered from up here. So that's kind of how you have to think when you see a proof like this. All right, so let's look. All right, so D bisects AC. So how do we know that happened? It was given. Remember, your givens are first. All right, so this one kind of puts the givens out of order, but that's okay. So it's basically a logical path. So from this statement, what did we learn? Well, we learned that AD is congruent to DC. Why do we know that those 2 are congruent? Well, we know what bisects mean. So then we put definition. I do this little funky like in up at the top of segment bisector. Okay, next part, BD is perpendicular to AC. That was a given. So another way to set up a proof instead of putting all your givens at the beginning is to use a given, break it up. Then use your other given and then break that up. Okay, you can't really see. Use a given, break it up, okay? So ADB and CDB are right angles. Well, how do we know that? So ADB, CDB. How do we know that? Well, we know that because those 2 lines are perpendicular. So definition, or you can say, you can just say definition of perpendicular. Okay, so since they're right angles, that makes them congruent, right? Because right angle is 90. So right angle, right angle, right angle, they're always going to be 90. So then they're congruent to each other because all right angles are congruent. All right, next, how do we know that BD was congruent to itself? They share that side, but what is that called? That's called reflexive. Okay, so do I have 3 congruent parts? 1, 2, 3. Yes, so then can I say that these 2 triangles are congruent? Yes, but make sure that they're in the right order, like SAS, SSS, AAS, something like that. Okay, so these 2 triangles are congruent, we said earlier, by SAS. Now, wait a second. Why is there another step? All right, do you see here? See how it doesn't have proving 2 triangles? That doesn't matter. Even if this statement is proving an angle is equal to an angle or a side is equal to a side, you still have to prove the 2 triangles are congruent first. Okay, you still have to prove that the 2 triangles are congruent first. This is where that weird thing CPCTC came in from yesterday. So if you didn't watch yesterday's stuff, you need to go do that. Okay, remember CPCTC stands for corresponding parts of congruent triangles are congruent. Okay, so basically, since we showed that these 2 triangles are congruent to each other, then I can say that any of their corresponding parts are also congruent. So remember, corresponding means same spot in 2 different shapes. Okay, so same angle in 2 different shapes, same side in 2 different shapes. So since we proved that these 2 triangles are the exact same, then I can say that AB is congruent to CB. Oh, I should put 3 on there. So then this would be CPCTC. Ooh, not S. What happened? Okay. So if you ever see something that says prove and it's not 2 triangles, you still need to prove 2 triangles, and then that next statement will always, well, not always, but most likely be CPCTC. Okay? All right, let's look at the next one. All right, so this one's more of a solving one. Okay, so let's look. Which postulate can you use to prove that they're congruent? All right, so far, we've got these 2 sides are congruent. If this is 90, that means this is 90, and then they share this side, so that is SAS. Okay. So angle ADB is 3x minus 12. Well, we know ADB is 90 degrees. So I would set 3x minus 12 equals 90. Okay, so you can solve for that yourself. Okay. BC is 3y minus 7. And AB is y plus 21. Well, since I just proved that these 2 triangles are congruent, then I can say that their corresponding sides are congruent, CPCTC. So then I can set them equal to each other. Okay, you can solve for that as well. Bloop, bloop. All right, and then angle C is 115. And then angle A is 4z minus 5. So since we just proved that those are congruent, that these 2 triangles are congruent, then we can say that their corresponding angles are congruent. You could also argue that this, since these two sides are congruent, this triangle here is isosceles, so then these two angles are congruent. That would be another way to set that up or think about it. All right, so solve for that on your own. All right, so let's look down here. So remember, you got to think about, you got to always label, okay? So this is triangle is congruent to triangle, so I'm not going to be using CPCTC, okay? Most likely. All right, so let's look. All this is given, but first remember you have to label first. Okay, so angle 1 and 2 are right angles, so let's go ahead and make those right angles. So that means they're congruent to each other, right? All right, AD is congruent to DC. Oh, that's already marked for us. Thank you. Okay, so now I would always try to prove it first before you put it in your proof. Okay, so then I know that I need 3 congruent parts, right? Right now I only have 2, so I need that third part. It's congruent to itself by reflexive. Okay. All right, so now I'll prove that these are congruent by side, angle, side. All right, so let's put this in our proof. All right, so this proof puts its givens in one statement. That's okay. I'm fine with that. All right, angle 1 and angle 2. So we know that they're right angles, but how are they congruent? Well, we know that all right angles are congruent. All right, BD is congruent to BD. How do we know that? Reflexive. Okay, so then I've got 1, 2, 3 congruent parts, so I can prove that these two triangles are congruent. How do we prove it? By side, angle, side. All right, next one. I'm going to try to leave some of this up to you. I'm going to help you for sure. Okay, you know the first one is given, right? And if you look, this is also given. Very important. When it tells you lines are parallel, always extend them. So extend lines. Okay, when you're told that lines are parallel, you need to be on the lookout for alternate interior angles. And you need to be on the lookout, and that's a popular one. Corresponding is also popular. You could use other ones, but those are the most popular, okay? So if you see parallel, think, oh, I need to be on the lookout for these two. So I'm going to go ahead and extend those 2 lines. It'll kind of help us. All right, so they're parallel. Okay, AC bisects EB. AC bisects EB. So then I know that these two are congruent. Parallel does not mean congruent sides, all right, unless it's a parallelogram, but that's later. All right, so right now I've only got 1 congruent pair, and I need 3. So I know that angle 1 and angle 2 are congruent by vertical angle, so now I've got 2. All right, I cannot assume anything about these 2 sides. All right, so let's look. So let's say that we have parallel lines, okay? Then you always got to think, well, remember, we did parallel lines cut by a transversal, right? So I'm going to draw a transversal. All right, so if I just draw this transversal, and then I draw those two lines, that's basically what I have right now. So then I can look, this right here is angle B, and this is angle E. All right, those are alternate interior angles. What do I know about alternate interior angles? They are congruent. Okay? So now do I have three parts? Yes. So 1, 2, 3. So how would I prove that these two are congruent? We've got angle, side, angle. All right. So let's look at here. So AC bisects EB. So what did we learn from AC bisecting this? Well, we learned that ED is congruent to DB. How do we know that? Definition of segment bisector. All right, the next one's given. Okay, so we found out from these parallel lines, okay, and we drew a transversal that angle B is congruent to angle E. Okay, how did we know that? Alternate interior angles. Okay, and then how did we know that 1 and 2 were congruent? By vertical angles. So angle 1 is congruent to angle 2. And so we proved that these two triangles are congruent by ASA. So you really got to know your vocab. If you don't know your vocab, you need to go back and look at your vocab from last module or make some vocab cards. All right. So let's look at this one. All right. So angle B is congruent to angle D. AB is congruent to ED. Okay, cool. So angle B is congruent to angle D. I know this because it's given. Angle 1 is congruent to angle 2. Well, wait, it didn't give us that. How do we know that? Okay, I know that because they're vertical angles. So vertical angles are congruent. Angle A is congruent to angle, let's look. Okay, how could that happen? Okay, well, think about it. We know that all triangles add up to 180, right? So if these two have the same angles, then it forces that third angle to be the same, right? So angle E. Oh, that is not an E. Okay, so we call this the third angle theorem. Okay, but remember, angle doesn't help us solve anything for congruency. All right, so we didn't really need this information. Okay, so if we didn't use that, okay, just look at that. Okay, how would I know that these two triangles are congruent? Do I have three congruent parts? Yes. Okay, I've got angle, angle, side. You can do side, angle, angle as well. Alright, so let's write the congruent statement. So remember I told you to write it in the same order. Alright, so I'm just going to start with, I'm going to do B, A, C. I can start with whatever I want. Okay? Now I have to name the other one in the same direction. So here I started the angle with one arc, so that means I'll start with D. Then I went to the past the congruent side, so past the congruent side to E. and then I went to the middle C. All right, so this one you would just write like, based on this, you can just do BA, because they're the first two letters, is congruent to DE, because they're the first two letters. Then you can do AC is congruent to EC, because they're the second two letters. Ooh. And then you can do BC is congruent to DC. So sometimes you don't even need to look at the triangle. You can just base it off of the letters that you got. All right, so let's look at this one. All right, so you do not have to do this. All right. All right, so let's mark it first. So given angle B is congruent to angle D, AB is congruent to ED, and we need to prove this. Remember, so that's not a triangle, but you have to prove the triangles are congruent first. Then use CPCTC. Okay, so right now in my triangle, I only have two congruent parts. I need three. So I know that these two are congruent based off of vertical angles. So this would be congruent by angle, angle, side. Okay, because that side is not included in between them. So for it to be angle, side, angle, the side would have to be here. Angle, side, angle. But since it's not in between the two angles, then it's angle, side, side. I'm sorry, angle, angle, side, or side, angle, angle. Okay. It's more proper to write angle, angle, side, but if you write SAA, totally okay. All right, what do you know about vertical angles? They are congruent. How does the fact that AB is congruent to ED help you? Okay, we get to compare congruent sides. What are the angles of each triangle, or what angles of each triangle are congruent? We know angle B is congruent to angle D, and we know angle 1 is congruent to angle 2. What postulate can you use to prove the triangles are congruent? All right, so angle, angle, side. All right, so now we're going to take all this information. This is how you think about how you think in a proof. Okay, we're going to put it down here. All right, so this was given to us. All right, angle 1 is congruent to angle 2. Vertical angles are congruent. Okay, so we've got 1, 2, 3 congruent parts, so I can say these two triangles are congruent. Since they're congruent, all their corresponding parts are congruent, so that means BC is congruent to CD by CPCTC. All right, so I will do another video for the triangle discovery. Okay, this is kind of Tuesday and Wednesday work, okay? So tomorrow I'm not going to give you more stuff. I'm just going to say, except for maybe a Delta Math assignment. But other than these two things, I'm going to give you a couple days to work on them, okay? It's a lot going on, okay? And then I'll kind of give you something new on Thursday and Friday, okay? All right, so I'm going to do a different video, part 2 for this one.